All right, here we go. All right, how can I dilate a function? First of all, what's a dilation? Think of your pupils. What happens when you go out into the sun? Do your pupils, when you go out in the sun, they get bigger? They get smaller. So they change size. That's all a dilation is, a change of size. All right, a dilation changes the graph by stretching or compressing it vertically or horizontally. All right, let's start off with a very basic graph. We're not going to dilate this or do anything to it. This is your basic parent function graph. I realize I'm cheating, but that's okay. You'll live. I'm working smarter, not harder. There's a difference. All right. I do that freehand. Or not. I just lied to you. Thank you. Promise that won't be the only time. All right, let's graph this. Let's make a function table. And I know I stamped mine, so it's a lot faster than yours. I get that. So I will slow down. I'll actually zoom in a little bit more too. How many points should I have for a parabola to graph it? I would prefer at least 5. So, is this parabola moving left to right at all? Is there anything in parentheses that tells us to move left to right? No. So it's going to be on 0. So x is going to be 0, and then I'm going to choose 2 points to the left of it and 2 points to the right of it. So I'm going to choose 1 and 2 and -1, -2. And now I'm just going to square this. 2 squared is 4. 1 squared is 1. 0 squared is 0. -1 squared is 1. -2 squared is 4. And honestly, the reason I use my stamp is because I wanted you to be able to look at the difference. We're going to graph 3 graphs on this piece of paper. We're going to graph a basic one, and then we're going to stretch one, and then we're going to compress one. So, God bless you. All right, so 0, 0, 1, 1, -1, 1, and 2, 4. 1, 2, 1, 2, 3, 4. Over 2, up 1, 2, 3, 4. Here's some useless trivia for you that you'll never use in your life, but you might. All right. So this parabola, since it's not being dilated, opens at a certain rate. It goes up 1 over 1, up 3 over 1. The next point would be up 5 over 1. And what do you think the next point would be? Well, it went 1, 3, 5, 7, 9. So that's the way a parabola that's not being stretched or compressed opens at a rate of 1. It goes up vertically 1, then 3, then 5, then 7. Just some useless information that I thought I'd share. I'm full of useless information. All right, let's do a vertical dilation. So now I'm just going to go over on the left-hand side, and we're going to squeeze one in here. Vertical dilation. And this is going to be g of x equals 2x squared. How do I know it's vertical, not horizontal? Just by looking at that. Anyone? Do you see parentheses up there? Then it's not, then it has nothing to do with horizontal. If there's no parentheses, there's nothing horizontal. That's honestly the easiest way. All right, let's make a function table. X, y equals 2x squared now, and let's use the same exact coordinates. 2, 1, 0, negative 1, negative 2. Can you use a calculator on this if it makes you feel warm and fuzzy? Sure, that's fine. So 2 times 2 squared. 2 squared is 4. 4 times 2 is 8. And let me know if I'm going too fast, please. All right, she wanted it up, you wanted it down. Is that what you meant, I assume?
Yeah.
All right. That's like I get confused when someone says, hey, can you turn the air conditioner up? Wait, you want the air conditioner to blow more, or you want the temperature to go up? It's confusing to me, and I don't like to be confused. All right, more useless stuff that you didn't need to know, sorry. 1 squared is 1, 1 times 2 is 2. 2 times 0 squared, 0 squared is 0, 0 times 2 is 0. Before I even go any further, since this is my vertex, what should my next number be? If I plug in negative 1, what should it be? 2. And then what should negative 2 be? Yes, let's prove it. 2 times negative 1 squared. Negative 1 times negative 1 is positive 1. 1 times 2 is 2. 2 times negative 2 squared. Negative 2 squared is 4. 4 times 2 is 8. So let's go ahead and graph this and see what the difference looks like between this one and our original one, our parent function. So once again, I'm at 0, 0 over 2 up 1. At 2 up 1. Over 2, uh-oh. I made a mistake. Actually, I did not make a mistake. We'll just count these by 2s. Good idea. So we'll count that as 1. We'll count that as 2. Chloe, I don't know if I liking this idea. I don't like that idea. Because that's something our old book Carnegie would do, is they would have different values on the x-axis and the y-axis, and it would skew the graph, and I always hated that, so I'm not going to do that now. So let's go back 30 seconds in time. There's 0, 0. Let's go over 1, up 2. Over 1, up 2. Over 2, up 8. 1, 2, 3, 4, 5, 6, 7, 8. Over 2, up 8. And what do you notice about this graph compared to this graph? It's skinnier, yes? So what's it skinnier by? 2, because instead of going up 1 over 1, it went up 2. And instead of going up 3, it went up 6. So this graph is actually skinnier. It's like you put your foot here and pulled up the arms. And I knew that because this was greater than 2. And on our foldable that we made yesterday, it said that if A is greater than 1, it stretches. So we just stretch the parabola. All right, so what's the opposite of stretching? Well, stretching is a form of dilation, so compressing. So let's do one more, and we're going to compress it. And I'll try and be neater on this one. Keyword is try. All right, let's do our function table. This one is g of x equals parentheses 2x squared. And this is a horizontal dilation. So this one should be a push down, smush down graph. Keyword is should be. So let's use our same points. 2, 1, 0, 1, 2. 2 times 2 squared. 2 times 2 is 4. 4 squared is 16. That's not going to fit on our graph, but that's okay. We'll overcome the adversity. 2 times 1 squared. 2 times 1 is 2. 2 squared is 4. All right, 0. 2 times 0 squared is 0. 2 times negative 1 is negative 2. Negative 2 squared is 4. And let's see, 2 times negative 2 is negative 4 squared is 16. So that's not going to fit on our graph, but that's okay. Yeah. Give me just a second. I'll make it a little neater in just a minute. Let me try and think the best way to do this. I don't think that will show up. All right, so really what this is here, okay, so let me plot my points. What points did you need, Alexa? So 216 over 2 up 16. That's going to go off my graph, so I'm not even going to.
It's 2 what?
Oh, it's right here. 2 times x. Yeah, so whatever x is, I substitute in for x. Yeah, I should have moved my graph over. That would have given me more room. I believe so. I hope so. Unless I made a mistake, which is possible. I would hope I didn't make a mistake, but I might. All right, so over 1 up 4. Back 1 up 4. Yeah, well, that's because it's a horizontal dilation. A horizontal dilation is the same as a vertical stretch. So I was mistaken. That's where I messed up, Ryan. Is I was thinking that it was a vertical stretch, but it's not. So that's why they're both skinny. That's not exactly what I wanted, but
What did you go for before?
I did 216, 1400. So I did it right. It's just I said it wrong. It's a horizontal dilation, and really, since it's, let's look at our paper. Since it's horizontal and it's greater than 1, it's a horizontal compression, which is the same as a vertical stretch. So it's the same exact thing. One affects a B term, one affects a term. Okay. I don't know why the book does what it does. Sometimes it does some wonky stuff. I'm sorry. All right, let's get into something easier, which we actually just talked about. All right, example 1. That was just information. That really wasn't an example for you. All right, this is what your homework is like. This is what your homework is like. All right, you have 4. You only have 6 problems for homework, and 4 of them are like this.
This was yesterday's homework, isn't it?
No, this is today. Brian, what are you doing? Okay. Just wait till my lesson's done, please. All right, describe the dilation and reflection as it relates to the parent function. Alright, I'm going to make this negative 2/3 x squared. Even though we really haven't talked a lot about reflections, we're going to right now. So we have 3 of these. So that's A. B is y equals the absolute value of 5x. And C is y equals 3.5 times the absolute value of x. So what your homework says is describe each dilation and reflection as it relates to the parent function. So this is exactly like your homework. And this one, example A, may or may not be problem number 15 from your homework. I think it is, though. So my question to you is, what is going on with this problem? What is going on here? Does anyone have any thoughts whatsoever? What is going on here? What is the negative telling us to do? Is the negative in parentheses or outside of parentheses? So is that a vertical reflection? Is it a vertical or horizontal reflection? Let's look at our sheet here. So it's negative across the x-axis. So yes, that is a vertical. Hold on. I want to write that a little bit differently. I don't like that because that's confusing to me. So it reflects over the x or y axis? X-axis. I'll answer that question. And what is the 2/3 doing? Is that stretching or compressing? Anyone? Thank you. It is a fraction, so it's compressing. And it's actually a vertical compress. I like that better because it's not in the parentheses, because there is no parentheses. All right, how about B? What's going on with B? First of all, is there any reflections? Yes, James? Yep. We have a negative, right? There's no parentheses, right? So it's not affecting our B term, it's affecting our A term. So if we go back to our sheet here, maybe let me fold it. If we go back here, if your A term is negative, it flips it over the x-axis. It reflects it over the x-axis. So this is our A term right here is 2/3, and it's negative. So it's going to flip over the x-axis. So this parabola is going to be frowning. It's opening down. So now the 2/3 is our A term, and isn't 2/3 a fraction? So it's between 0 and 1. Yes, so that means it's compressing. So it's a reflection over the x-axis, and it's a vertical compression. All right? If there's several homework problems like that. If you get stuck, let me know. I'll gladly help you, or I'll go over them tomorrow when you get here, when you come in. Like, let's look at number 2. Absolute values are the same thing as parentheses, so that's my B term. So remember, this is your B term, so it's a horizontal dilation. So what does it say? Horizontal dilation. If it's greater than 1, it's a horizontal compression. So for this one, our only answer is compress, horizontal compress. Horizontal compress. Because it's greater than 1. Last but not least, is this inside the parentheses? Inside the absolute value. So this is your A term. This is your A term. Is it anything telling it to reflect down? Nope, it's not negative. So it's 3.5. So let's look at our little cheat sheet. Greater than 1 is a, so this is a vertical stretch.
How do you do it
Because it's outside the parentheses.
If it's horizontal,
It's inside. And those absolute value can be considered parentheses. All right, we're making progress. What's that? Yeah. All right, we have one more graph we're going to do. I think, well, give me just a second. I want to make sure it's relevant to your homework so that you know how to do your homework. All right. So this is example 2. And this is just like your homework problem. Graph g of x. Graph g of x. The transformation of f of x equals x squared compressed horizontally by a factor of 2 and reflected in the y-axis. Oops, I'll move it up so you can actually see it. All right, let's try and break this down. Graph g of x, the transformation of f of x. F of x is x squared. It's compressed horizontally. So compressed horizontally means it's going to affect our b term. So it's going to be in our parentheses. So y equals parentheses, compressed horizontally. So that's going to be 2x by a factor of 2 and reflected in the y-axis. Which one causes the y-axis to reflect? You're close. You're really close. Kind of what I was going for there is the A term causes it to reflect down. The B term causes it to reflect horizontally. So A controls vertically, B controls horizontally. So it says it wants it to reflect horizontally. So we're going to put a negative inside our parentheses. Can we now make a function table from that and then graph it?
Yeah.
All right, if we can, we're done for today. And you have a brief assignment. So let's see if we can. So this is a parabola, so how many points should I have? Is anything telling it to go left or right? Nope, so I'm going to use 2, 1, 0, negative 1, negative 2. Unlike that other one, I'll put my function table on the left so I don't have to worry about screwing it up or jamming it in. I didn't screw it up, I just jammed it in. So negative 2 times 2 squared. Negative 2 times 2 is negative 4. Negative 4 squared is 16. All right. Negative 2 times 1 squared. Negative 2 times 1, It's negative 2. Negative 2 squared is 4. Negative 2 times 0 squared. Negative 2 times 0 is 0. 0 squared is 0. Negative 2 times negative 1 squared. Negative 2 times negative 1 is 2. 2 squared is 4. Negative 2 times negative 2 squared. Negative 2 times negative 2 is 4. 4 squared is 16. Do we have the same numbers, or does it? Are these the same as this? That's what I'm trying to say. I don't know why I can't. All right, now just graph it and we're done. And then you can start your assignment. All right, so over 2 up 16 is not going to fit on my graph. Is that the end of the world? Kayliana, is that okay? It's fine. I just know it's going to be way up there. Over 1 up 4. Or if I wanted to, I could count it by 2s. That would have been an option. And congratulations, you just graphed it. All right, you have an assignment. I think it's 1, 2, 3, 4, 5, 6 problems. The 6th problem might be a little bit challenging, but this is an honors course, so I should